All right, moving on to proving triangles similar. This is 6.2. If you remember back when we were proving congruent triangles, we had, I believe, 5. We had side, 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 angle, side, angle, hypotenuse, leg, and angle, angle, side. We had 5 ways to prove triangles were congruent. Well, for similar triangles, we have 3 ways. We have angle, angle similarity. We have side, side, side similarity. And we have side, angle, side similarity. Now, please keep in mind, when we talk about angles, the angles have to be congruent. Corresponding angles are congruent in similar triangles. And when we talk about sides, they have to be proportional. Okay, so it's a little bit different here. All right, so to prove 2 triangles are similar with angle-angle similarity, we would say if, let's say, angle A is congruent to angle D and angle B is congruent to angle E, then the 2 triangles are similar. So let's name these guys. Let's say A, B, C, and D, E, F. So what we're saying is if angle A is congruent to angle D and angle B is congruent to angle E, then triangle ABC is, oops, I'm sorry, I wrote that wrong, is similar to triangle DEF. Now, yesterday I said all 3 of the angles have to be congruent. Why do we only have to prove 2 to prove the triangles are similar? Come on, somebody, don't let me down. Because they add up to 180, and if these 2 are congruent, then these 2 have to be congruent because of the third angle theorem. Good job, third angle theorem. That's what I like to hear. The third angle theorem says if these 2 guys are congruent to these 2 guys, then obviously these 2 are going to be similar because, let's just make up some numbers. If this guy is 60 and this guy is 70, it means this guy is 60 and 70 and 70 add up to 130, which means they both, C and F, would have to be 50 degrees, right? So the third angle theorem allows us to only prove 2 of the corresponding angles are congruent to prove triangles are similar. Are you with me on this?
Yes.
Good. Let's move on to the next one. Okay, now the next one is side, side, side similarity. And what that means is, let's name our triangles again, A, B, C, D, E, F. Now remember, when we're talking about sides, they have to be proportional. So what we're going to say is, if, in this case, AB, side AB is in a ratio with side DE, if the ratio of those 2 sides equal the ratio of BC over EF, and if side CA is in a ratio with side FD, if all 3 of those ratios are congruent or equal, then the 2 triangles are similar. For instance, if we had, let's make up, let's just go 3, 7, and 10. And if this guy was 1.5, and this guy was 3.5, and this guy was 5, well, then we could say 3 over 1.5 equals 7 over 3.5, which equals 10 over 5. And when we reduced, it would reduce to 2 over 1, 2 over 1, 2 over 1. So all three of these ratios are equal, so therefore we can say these two triangles are similar by side, side, side. Yes?
Wait, so it doesn't, do the fractions matter? Like,
Here?
or however, like, did it have, does one have to be on top always, or
It doesn't matter, no. It doesn't matter. Like, I always try and put the smaller ones on top, just out of habit. But in this case, since I named these ABC, I left it. So if the three sides are all equal ratios, then again we can say triangle ABC is similar to triangle DEF. Okay, and finally, again, we'll name them A, B, C, D, E, F. We can say if, again, the ratio of AB over DE and the ratio of, let's say, equals the ratio of AC over DF, and angle A is congruent to angle D, then triangle ABC is similar to triangle DEF. Move that up for you guys. All right, now we have to be careful this time. We're saying if line segment side AB or line segment AB over line segment DE, if this ratio is equal to this ratio, AC over DF, and that the included angles are congruent, then triangle ABC is similar to triangle DEF. Remember, it has to be the included angle. That's a very important part. Remember, direction doesn't matter, but order does. So it has to be these two guys, these two angles, and then these two guys. The order matters. Are we good there? So those are our three similarity statements that we're going to be able to use throughout this unit. So let's put them to use. Determine how the triangles are similar. Include any similarity statements. All right, so we got to look at this, and what do we know here? What do we know about these two triangles? Obviously, hopefully you can see that it's triangle EDC and triangle EFG. So what do we know about those two triangles, guys? Go back to congruency. Yes?
We know that the two interior angles are congruent.
That's right. We know that angle DEC is congruent to triangle angle FEG. How do we know that? Come on, guys. It hasn't been that long. Vertical angles are congruent. Okay? And don't we know something about the other two angles? How about angle C and angle G? Don't we know something about those two? How do we know they're congruent? Alternate, there it is. Parallel lines. You should be thinking those parallel line theorems. Alternate interior angles are congruent. Now we only need to prove two corresponding angles are congruent to prove triangles are similar because of third angle theorem, right? So what we can say is angle C is congruent to angle G by alternate interior angles, and we can say that angle CED is congruent to angle GEF F by vertical angle theorem. And since we can say that, we can go ahead and say that triangle EDC is similar to triangle, now I want to be careful, EDC, so EFG. Order is important. And how do we know that? By angle, angle. Are we good with that? Have I confused anybody? Left anybody behind? All right, then let's go on to the next one. So the two triangles, hopefully you can see them, are going to be MNL and QPL. All right, so what do we know about these two triangles? So we're trying to prove triangle. Let's go ahead and write down what triangles we're trying to prove. We're trying to prove the triangle MNL is similar to triangle QPL. Can we prove those two triangles are similar? Same shape, different sizes. Do we know anything about the angles or the side length? They share angle L, that's right. We can say that angle L is congruent to angle L by reflexive property, right? Do we know anything about the other two sets of angles? So what matches up? M and Q match up. Can we say anything about those guys? No, that might work at some point, but we know they're congruent. How do we know they're congruent? No, but corresponding angles. Same side interior would be this angle here, and they would be at 180, which are true. They are supplementary, but we know these two are congruent by corresponding angles. So I can say that angle M is congruent to angle, I got to put PQL to make sure I'm being specific about that one. Angle M is the only angle there, but I've got two angles here. I've got angle MQP and I've got angle PQL, and I want to use PQL. So this one I know because it's reflexive. I don't have to write this, but reflexive. And these two guys are corresponding. So now I can say that triangle MNL is similar to triangle QPL by angle-angle similarities theorem. Excuse me? Okay, let's move on. All right, so now we have some side lengths, don't we? So we're probably going to prove this guy by maybe by side, 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 or by side, angle, side. What do you guys want to use? Any ideas? We could use side, angle, side because we know these two guys are congruent, right? So we know those two angles are congruent by vertical angles. Now that means if we're going to use side, angle, side, we got to match up two sides. I got to match up either a side, this side with something over here, and this side with something over here. Now the question is, what sides do we match up? How would we know? What's that? Well, we have an idea. So take a look. We know that this side, this triangle here, has got to match up something with this triangle over here, right? So let's just name these guys real quick. Let's go A, B, C, and let's go D, E over here, okay? All right. Well, we're going to try and match up triangle ABC with some triangle over here. We don't know if it's DBE or EBD. But if you notice in triangle ABC, What's the smallest side in triangle ABC? It's 5, isn't it? Well, what's the smallest side in triangle BDE? 18. So if any two sides are going to be in a ratio, it's going to have to be the two smallest sides, right? So let's see if this works. So we'll go 5 over 18 should be equal to, if we're going to use side angle side, these two should be in a ratio, right? And let's go 15 over 54. Do you understand how I decided that this should be the ratio if these two triangles are going to be similar? Yeah, the two smallest and the two biggest. If these two triangles are going to be similar, these would have to be the ratios. In fact, we could put, we don't need it, we could, if we wanted to go side, 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 we could put this guy in there as well. Well, 5/18 can't be reduced, can it? So this, if it's going to work, is going to be our scale factor. So 15 divided by 3 is 5. Hopefully 54 divided by 3 is 18 also, and in fact it is. Now I got to admit, this one's pretty strange, so we would have to maybe cross multiply to get there. I don't know how you get 12 down to 5. But this is enough to prove, I know we could get this to 15 over 18 because we prove these two triangles are similar by side, angle, side. So I can put triangle ABC is similar to triangle DBE by side, angle, side similarity postulate. Now we could have done side, 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 but this guy is just too much of a mess to even worry about. If we multiplied this by 5 and then divided by 12, we would get to, so if we multiply this by 5, that's not going to help. Okay. Thank you. All right, so it looks like we're going to try and prove that triangle WXV is similar to triangle WYU. So let's do this one by side, side, side. All the angles, excuse me, all the lengths are pretty good. We should be able to do this. So WX over WY. So WX is 15. Be careful here. What's WY? 21, isn't it?
Yeah.
And then XV is 40 over 56. And VW is 20. VW over UW, which is 28. Do you guys understand how I came up with those three ratios? Please speak up if you don't. We're trying to prove that this triangle is similar to this triangle. What does similar mean? Same shape, but different sizes. When we reduce, 3 goes into both of those. 5/7. 8 goes into both of those. And 4 goes into both of those. So the two triangles are similar by side, side, side. And remember, when we talk about side, 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 we mean they are proportional. 15 over 21 equals 40 over 56, which equals 20 over 28. They are proportional. Okay, let's turn the page. All right, let's do one more of those. Which one would you like to do? Which one do you think is necessary?
The one that looks really weird.
Which one? This one? Okay. All right, so you can see that we have parallel lines here, right? And these parallel lines are cut by a transversal. So I know that this angle is congruent to this angle by corresponding angles. All right, so I know that angle CMP is congruent to angle RPQ, and I know that by when lines are parallel, corresponding angles are congruent. So now, if I want to use side angle side, I need to prove that these two guys are proportional and these two guys are proportional. So what we're trying to prove is that MC over PR is equal to MP over PQ. So I already proved that angle M is congruent to angle P, so now if I can prove that MC over PR is equal to MP over PQ, then I will know the two triangles are similar, the same shape. So let's see, we've got 54 over 33. 54 over 33, and should be equal to 36 over 22. Okay. So what do you think? Are those two guys proportional? Anybody? Kind of hard to tell, isn't it? Will 3 go into these guys?
Yeah.
Okay, 3 will go into 54. How many times? What's that? 18 times? Good job. And 3 goes into there 11 times. 2 goes into here 18 times, and 2 goes in there 11 times. So they are proportional, aren't they? This is Brad. I'll send him up. Alrighty, bye-bye. Derek, you need to go up to the front office. So I can say that triangle CMP is similar to triangle RPQ by side angle side similarity theorem. All right, your job this weekend is to do 1 through 14. 1 through 14. You guys can do it. I have faith in you.